Topic for today, complex numbers. A complex number is given by z equals to a plus bi, where a is the real part and bi is the imaginary part. We want to see how we represent a complex number in the complex plane. So the x-axis in the Cartesian coordinates represents now as the real part, re for the complex number, and the y-axis will be represented by im for imaginary part of the complex number. So imagine we want to represent the complex number 2 plus 3i in the complex plane. It means I will move two points to the right and 3 up, and therefore the vector OA is given by this. We also can calculate the modulus and the argument form of any complex number given by z equals to x plus yi. We also can represent it this way as a vector, right? And the notation for a modulus is this one, as we know already for the real, we already know it, and it's given by the x squared plus y squared. And if we want to calculate the argument or the angle of a complex number, we do tan minus 1 y equals to x is related to trigonometry, the angle of a complex number. Let's see an example. Let's suppose we have 5 plus 12i. If I want to calculate the modulus of 5 plus 12i, I do the square root of 5 squared plus 12 squared equals to square root of 169 equals to 13. If I want to calculate the argument of 5 plus 12i, applying the formulas we saw before, is the 10 minus 1 of 12 over 5, which gives me 1.1760. If I want three significant figures, is 1.18 radians. If I want to represent in the complex plane, I have 5 points to the right and 12 up, and this is my vector. This is my complex number. B. If I want to represent, for example, minus 3 plus 4i, how do I represent in my complex plane? I go minus 3 to the left, plus 4. So it's given by this, where this angle is theta and this angle is alpha. Therefore, if I want to calculate the argument or the angle of minus 3 plus 4i, I must go to pi and subtract alpha to give me the theta, which is the one I want to know. Therefore, pi minus the definition of the argument is 10 minus 1, the 4 divided by 3. Gives me 2.214 using three significant figures, correct to three significant figures. Another example, just to cover all the type of examples we can have, going to all the quadrants. This one, 12 minus 5i, it is in the fourth quadrant, where theta equals to minus alpha. Therefore, if I want the argument of 12 minus 5i, I do the 10 minus 1, 5 divided by 12, and I get 0.395 using three significant figures. The modulus, as we know, we apply and we know it's 13. It's the 12 squared plus 5 squared, and I have the solution. Going to the last example, minus 4 minus 3i, what do I get? I get minus 4 to the left and minus 3 down. So this one is my alpha. All of this is my theta. I want to know theta, which is given by minus pi plus alpha, where minus pi plus the argument is 10 minus 1, 3 over 4, which is minus 250 to 3 significant figures.